In this video, we're going to be looking at conditional trigonometry. Okay, the reason why I call this part conditional trigonometry is because they will always give you a condition or an equation, right? And ask you to solve for question based on the given equation or trig ratio. So this kind of questions we are always going to be drawing a right-angled triangle. We're going to always be drawing a right-angled triangle. And this is how we're going to draw our triangle in this case, right? So, firstly, you're going to look at this part, right? You need the sign to be isolated. So the trig ratios must all be isolated. So here we're going to isolate the cos beta, right? Now let's isolate the sign first, the one thing at a time. So we're going to look at this first. So 1, I can see that 13 sine of alpha is the same as -5. So I'm moving the 5 to the other side of the equation. Then the next step is to divide by 13 both sides. Then I can see that this 13 will cancel that. So I have sine of alpha is the same as -5 all over 13, right? And then now we need to draw a right-angled triangle. You see here they told you to draw a sketch, but this they will not always tell you. In this case, we are just lucky. They expect you to know that for conditional trigonometry, you're always going to draw a right-angled triangle. So now I'll show you the steps that you follow to draw a triangle. Firstly, you check the interval that is given, okay? And then they'll always give you positive angles. My experience tells me they always use positive angles. Remember, this is 0, that's 90. Okay, let me put degrees. This is 180. This is 270. And then this is 360, right? Remember, as we go this way, we're adding 90s, we're adding anti-clockwise, sharp. So these guys, they say we must move from 0 up until 270. Well, so I'm going to tick the relevant quadrants. From 0 up until 270, let's get that one. So this quadrant must be included because it's 0 to 90, and then 90 to 180 must be included. So I'm putting those to show that included. And then this one must also be included from 0 to 270. You might be tempted to move from here to there. Remember, we always move anti-clockwise. You're always going to be moving anti-clockwise, okay? So we have checked the condition. Now you check the sign of this, the sign of your ratio. So our ratio in this case is negative. And then remember this, we have all students take off, right? We have sine and it's negative. So sine is going to be negative in the quadrant of tan and in the quadrant of cos. And then now I can easily see that my triangle is going to be in the third quadrant. Wherever you have 2 dots, that's where your triangle is going to be. Okay, let's do this. Now I'm going to draw my right angle triangle here. It always moves from here. You go down, then you go up. Never ever go to the y-axis. It's always, if you are coming down, it's down, up. If you are going up, it's up, down. So it's either up, down, or down, up. Okay, perfect. And then now, after you do that, remember by definition, sine, we have sine, right? Remember sine is up over height, right? Perfect. So it's opposite over hypotenuse. So which means 5 will be my opposite and 13 will be my hypotenuse. So hypotenuse is always positive all the time. But because I'm below, the y-axis is negative below. You see, this is parallel to that side. So I'm going to have -5 here. which is really true because here I'm already having a -5. You see, so it's aligned to the negative y-axis, and then my alpha will just go there, right? And then I'm now going to do theorem of Pythagoras. Ne? When I do Pythag, I don't use the signs. Ne? I just use the number. So I know that I'm going to say 13 squared, which is my hypotenuse, and then I have to minus the 5, right? Minus 5 squared. Here I put plus minus basically. And then let's check that on a calculator. Square root of, let's see. Let's see, square root of 13 squared minus 5 squared, which should give us 12, okay? So this part here is plus minus 12. So it's either we're going to put plus minus or minus 12, right? So, but I can see that the x-axis this side is going to be negative because we are on the negative x-axis. So here I have -12. Then I'm done with solving the first ratio. Now I'm going to do the cos ratio this side. Ne? Okay, so remember to separate, we need to separate the cos as well, just like we separated the sine here. So when I have 13, right, cos of beta equals to positive 12. It was -12, it goes this side, it becomes positive. And then we need to divide both sides by 13 now. So 13 and 13. So we have cos of beta equals to 12 over 13. And then remember, cos is adjacent over height. And then we're going to draw our second Cartesian plane here. Guys, in this question, the only tedious thing to do is to draw the Cartesian plane. Once you're done with the Cartesian plane, the questions are already solved. It's very easy, né? But this is the most critical part of this question. So remember, it's 0, it's 90 degrees, it's 180 degrees, right? And then it's 270 degrees, and then it's 360 degrees. Okay, we're going to use those. They say you must move from 90 to 360. So from here, so this part is included. Then we have 180, this part is still included. Then up until 360. So this is our last part, right? So 90 to 180, 180 to 270, 270 to 360, right? And then we have all students take coffee. Okay. And we can see that cos is what? It's positive in this case. If cos is positive, we're either going to be in the 4th quadrant or in the 1st quadrant. So it means our diagram is in the 4th quadrant because that is the quadrant where we have 2 dots, right? Perfect. Remember, our quadrant always goes to the part where we have 2 dots. So it's going to be up, down, then up. Okay. And then here our angle is going to be beta, right? Because it's cos beta. Sharp cos, hypotenuse is still 13. And then the adjacent is this side, né? Is very close to B. So the adjacent is what? Is 12, right? When we do theorem of Pythagoras like we did here, we're going to get plus minus 5. But here we're going to take -5 because we're down. Okay, and then once you're done with this, you are basically going to be done with the questions. I'll show you why. Né? But firstly, we need to verify something. Always make sure that your hypotenuse is positive. So it's positive here, it's positive here. If you're going down first, this value here must be negative. You're going down, the value is negative. And then if you are on the negative side of the x-axis, the adjacent is always going to be negative. If you are on the positive side of the x-axis, the adjacent is going to be positive. Okay, so now we can now try the questions, right? So the first question, they want us to find tan A minus tan B. Remember, tan by definition, it's opposite over adjacent, right? So if I'm looking at A for tan for this part, I'm gonna have opposite, which is negative 15 all over negative 12. Then I'm going to minus, which is this negative sign. Then now we're going to look at tan B. So we have to look at this quadrant. Tan B in this quadrant is negative 5, which is my opposite, over adjacent, which is 12. And then here, when this negative will cancel that, so I'm going to have 5 over 12. Then this negative and that one will give me a positive, which will give me 5 over 12 again. So the denominator is common, so I can say 5 plus 5 all over 12, which is 10 over 12, which is 5 over 6, right? And that's finito, right? Basically, after you substitute here, you can press your calculator and just get 5 over 6, ne? Perfect. But I advise you to always just try to show the working out. Okay, now we have cos beta minus, sin beta minus alpha. Remember, sine beta minus alpha can be written as sine beta cos alpha. The sign is the same for sine. So if we have a negative here, you're going to have a negative, which is cos beta sine alpha. All right. Now let's substitute and see what we get. So when we substitute here, sin B is opposite over hypotenuse. So sin B, this part here is going to be negative 5 over 13. Cos alpha, it's adjacent over hypotenuse. So alpha is the adjacent is negative 12 over 13, which is our hypotenuse. Then we have a minus. Cos beta, it's adjacent over hypotenuse. So cos beta is going to be 12 over 13. And then sin alpha is here basically, right? It's negative 5 over 13. Sin alpha is negative 5 over 13. Perfect. And then now we can press our calculator for this part. Let's do that. So we're going to have AC. We're going to have negative 5 over 13. Then we're going to have minus 12 over 13. Sorry. Then you close, right? Then it gives you 60 over 169, right? 60 over 169. Let's write it down. So it's going to be 60 all over 169. Then we need to minus by this part. Okay, let's minus and see. So we're going to have, let's see what the part is. So this part is what? It's we have open bracket 12 over 13. Then we have a closed bracket, and then we have negative 5 over 13. And then we close, which gives us negative 60 over 69. Okay, so it's negative 60 over 169. I mean, why did I say 69? Let's check. It's 169. Okay. So here I can see that I'm going to have 60 plus 60 because of the negative and the negative, and the bottom is the same, so all over 169. You can easily check what the answer will be now. Okay, so we have 60 plus 60 being 120 over 169. So we just have 120 over 169. Okay, perfect. Let's now look at question 3. So C. Okay, so on C, let's see. The one cos alpha plus beta. Okay, let's check. Cos A plus B. Remember the identity for this compound angle is cos alpha, cos beta. If it's a plus, here you have a minus, sine alpha, and then you have what? Sine beta, right? And then by the look of things, I can see that cos alpha was this part here. So to save time, I'll just take it from there. And then I can see that cos beta was this part here. Then I have a minus, this minus, and then I can see that sine alpha was this part here, which is negative 5 over 13. Then I see sine beta. Sine beta was basically this part here, which is negative 5 over 13. Right. And then we just substituted everything. Now we're going to get the solutions. Okay. Let's see. So here, okay, using my brain here, I see that it's going to be negative 144 over 169, right? Then here I'm going to have negative, negative, and negative. So the final answer is negative. Because negative and negative will give me a positive, and then this negative and that, I mean, these two will give me a positive. But that positive multiplied by that negative, it's a negative. So which is 25 over 169. Then what does this give us? This is going to give us negative 1 in total. So your final answer is negative 1. Okay. Perfect. And then that's it for this